On September 28, 1940, the United States Army Air Corps ordered North American Aviation to gear up for full-scale mass production of the B-25 bomber. When designing these new aircraft, engineers had to factor in the harsh lessons learned from the air war already raging over Europe. This gave rise to two new versions of the airplane, the B-25C and the B-25D. They were built at different plants, Inglewood and Kansas City. But the bombers themselves were practically twins, differing only in the most minor details. The first major contract was signed in September 1940. It called for the production of over 800 B-25Cs. The following summer, the Dutch government ordered over 150 more of these bombers. On top of that, under the Lend-Lease program, plans were drawn up to build 150 B-25C-10 bombers for Great Britain. This was along with an equal number of B-25C-15 versions for China. In reality, though, these specific deals remained nothing more than paper plans. Ultimately, those countries received later production blocks of the American aircraft through Lend-Lease. The standout feature of the B-25C model was its new uprated engines. These were Wright Cyclone R2-600-13 engines. They delivered 1,700 horsepower each. They were paired with reliable Holley carburetors. The bomber finally received a modern autopilot. This would later perform flawlessly during the famous Doolittle raid on Tokyo. Engineers also kept crew safety and comfort in mind. The airplane was fitted with a de-icing system. A dedicated Stewart Warner cabin heater was also installed inside the left wing. The bomber's electrical system was upgraded to a 24-volt system. This allowed them to install new electrically operated bomb racks. The wing structure was significantly reinforced to handle higher stress loads. The old low-pressure braking system was replaced with a much more effective high-pressure system. Changes also made their way to the tail section. The retractable tail skid was replaced with a fixed one, enclosed in an aerodynamic fairing. To prevent the tail assembly from icing up at high altitudes, it was integrated into the de-icing system as well. The updated B-25C took to the skies for its first flight on November 9, 1941. Pilot Edward Virgin was at the controls. Ultimately, American factories produced over 1,600 of these bombers. Development was continuous. Modifications were integrated directly on the assembly line. For instance, after a few hundred aircraft rolled off the line, engineers decided to significantly increase the fuel capacity. From then on, the standard B-25C could hold 974 gallons of aviation fuel. If a mission called for even more range, additional tanks could be fitted into the fuselage and wings. This added another 710 gallons. To make the crew's job easier, a small glass astrodome was mounted right above the cockpit. This let the navigator easily take celestial bearings from the sun and stars. The Armament saw upgrades too. It featured modified Bendix Amplidyne machine gun turrets. At the same time, prominent carburetor air scoops were added above the engine cowlings. Eventually, the bomber was modified to carry even more ordnance. Racks for extra bombs were added under the wings. A specialized rack for a full-sized naval torpedo was mounted under the fuselage. This required further reinforcement of the airframe and updated electrical wiring. This upgraded version was designated as the B-25C-1. The next block of 150 bombers was known as the B-25C-10. They came equipped with a modern radio compass system capable of receiving remote navigation signals. They were also fitted with a much stronger cabin heating system and far more precise bomb sights. Later on, the B-25C-15 block came along. On this model, engineers redesigned the engine nacelles. Now, each cylinder had its own exhaust stack. This gave the engines a very distinct, aggressive look. This new exhaust setup was called the Clayton S-type system. The aircraft was also fitted with a reliable emergency landing gear extension system. Firepower got a major upgrade too. Instead of the old 30 caliber machine gun in the nose, they installed two 50 caliber machine guns. One was fixed and fired straight ahead. The other was flexible for aiming. On top of that, these bombers were specially winterized for the harsh conditions of the far north. In February 1943, the military contract was extended. A new production block rolled out, the B-25C-20. Pilots got better forward visibility on this one. They removed extra metal framing from the windshield. range was increased once again. A 215-gallon self-sealing fuel tank was mounted right in the bomb bay. Every other bomber in this run received an even bigger 335-gallon tank. It was also tucked away in the bomb bay. This special long-range version went down in aviation history under the designation B-25C-25. On June 28, 1941, a massive contract was signed to produce 1,200 B-25D and A-87 bombers. The first two of these aircraft rolled off the line in early 1942. One of them flew for the first time on January 3rd. It was piloted by veteran test pilot Paul Balfour. This was the very first B-25 Mitchell fully assembled at the bomber plant in Kansas City. After just a month of active flight testing, full-rate production kicked off. These bombers were built at the local facility. They worked in cooperation with General Motors Fisher Body Division. Initially, the B-25D was almost identical to its B-25C predecessor. Pretty soon, though, as new production blocks rolled out, underwing racks were added. They allowed the bomber to carry 6 to 8 bombs, each weighed between 100 and 325 pounds. In addition, the aircraft got self-sealing fuel and oil tanks. They also received heavy-duty air filters. An astrodome was placed behind the cockpit. They also started installing newer Bendix Amplitude turrets. A torpedo rack appeared under the fuselage. They fitted flame dampeners to the exhaust stacks. This helped conceal the aircraft in the night sky. The next major update was the B-25D5 block. Here, engineers seriously beefed up the nose armament. Instead of the old .30 caliber, they packed 3 50 caliber machine guns right up front. 2 were fixed and the third was flexible. This meant the crew could aim and return fire. Designers also upgraded the bomb sight. To help these bombers fly even longer distances, every third aircraft got a massive 585-gallon auxiliary fuel tank. It was installed in the bomb bay and it could be jettisoned mid-flight. Plus, to keep the crew comfortable at high altitudes, they really improved the cabin heating system. The B-25D10 version received even more useful equipment. These aircraft were specially prepped to survive the harsh conditions of the far north. They were fitted with modern compasses and a reliable emergency landing gear extension system. In the next production block, the designers introduced an improved Clayton S-type exhaust system. Then came the D-20 block. These bombers featured updated cockpit glass that gave the pilots a much better field of view. They also had heavy armor plating for the co-pilot seat. This seriously boosted survivability in heavy combat. The instrument panel was upgraded with new D14 gauges for precise monitoring of oil and fuel pressure. Self-sealing 250-gallon fuel tanks were installed in the bomb bay. Half of the airplanes received an additional 325-gallon tank. The B-25D25 version boasted portable oxygen units for the crew. Meanwhile, the D-30 series bombers went through even more rigorous winterization for flights in sub-zero temperatures. The last bomber of this type rolled off the Kansas City assembly line in the spring of 1944. Combat units flying these aircraft pushed them to the absolute limit. However, new challenges kept popping up on the front lines, so mechanics modified the airplanes right at their forward bases. Thanks to the incredibly rugged airframes of the B-25C and B-25D models, you could strap almost any armament onto them. That is exactly how a bold idea was born. Turn this bomber into a high-speed attack aircraft. The problem was that dropping bombs on nimble Japanese ships from medium altitude was highly ineffective. Experienced captains easily dodged the bombs, and calculating for windage during a long drop was virtually impossible. That is when General George Kenney, commanding the 5th Air Force, proposed a highly risky new tactic. He ordered attacks on enemy ships at mast height. The airplane had to make its attack run right on the deck at an altitude of about 250 feet. It came in at speeds of over 185 miles per hour. Under these conditions, the bombs were skipped at point-blank range straight into the side of the ship. This made the attacks incredibly accurate and devastating, but this tactic had its drawbacks. The biggest threat to the pilots now came from shipboard anti-aircraft artillery putting up a sheer wall of fire. To survive and suppress the flak, there was a desperate need to heavily arm the nose of the airplane. This turned it into a true airborne predator. They initially decided to test this unusual tactic on the A-20 Havoc. But those bombers had major drawbacks. Their bomb load was much too small, and they lacked the necessary flight range. Plus, there was a desperate shortage of these airplanes in the Pacific theater. The bulk of them were being shipped to the Soviet Union under Lend-Lease. With this in mind, Major Paul Gunn from the 3rd Bombardment Group and North American Aviation Field Rep Jack Fox came up with another solution. Instead of the A-20, they decided to use the much more powerful B-25 bombers. They pitched their bold concept to General Kenny, and he eagerly greenlit the initiative. Pretty soon, the first modified B-25C was ready for testing. The main idea was that the pilot could execute a rapid, low-level attack entirely on his own. He would not need a separate bombardier to do it. So they hard-mounted a bank of 4 forward-firing 50-caliber machine guns right in the nose of the aircraft. Each gun had a supply of 500 rounds of ammo. The glass greenhouse nose was completely removed and skinned over with sheet metal. But even that was not enough for the engineers. On the sides of the fuselage, inside small blister pods, they added 4 more of those same 50-caliber machine guns. They placed 2 on each side. This heavily armed bomber even earned its own nickname, Pappy's Folly. Right after the initial test flights, the side guns were moved further aft. They were moved closer to the airplane's center of gravity to improve its handling. General George Kenny was so impressed by the results of this modification. He immediately ordered the conversion of several more B-25s. By the end of February 1943, 12 of these aircraft had already been modified at bases in Australia. This fully outfitted the 90th Bomb Squadron, and by early March, these new B-25 strafers delivered devastating results during the epic Battle of the Bismarck Sea. Thanks to high-speed, ultra-low-level attacks, the B-25 became an absolute nightmare for the Japanese fleet. The concentrated fire from 8 forward-firing 50 cals literally swept the decks clean. It suppressed enemy anti-aircraft fire before it even started. A Japanese convoy heading to Rabaul consisting of 8 destroyers and 8 transports suffered catastrophic losses. They lost all 8 of their transports and half of their destroyers. The ships were either sent to the bottom or run aground in panic. Bombing accuracy during these mast height attacks hit an impressive 43%. Their ground attack tactics were just as devastating. In their internal bomb bays, the B-25s carried special cluster munitions. Each packed 123-pound parafrag bombs. These deadly fragmentation bombs were dropped on parachutes. This allowed them to evenly blanket a massive area. This is exactly how American crews shredded Japanese airfields and wiped out flak positions. Overall, the strafer concept was a massive success. By September 1943, at the airbase in Townsville, Australia, 175 B-25C and B-25D models had undergone this heavy modification. This outfitted 5 full squadrons with massive forward firepower. From then on, these heavily armed bombers were not just hunting ships. They started tearing up enemy rail hubs, ports, and supply convoys. Inspired by this success, Paul Gunn pushed the envelope even further. He mounted 3 more 50 cals right under the belly. He placed them between the nose and the bomb bay. However, this proved a step too far. The extra weight and drag severely degraded the aircraft's performance. It pushed its flight characteristics dangerously beyond safe limits. As a result, this specific layout and any further testing had to be scrapped. North American Aviation had been keeping a close eye on these field mods. They quickly picked up on Gunn's idea. They began factory installing 2 fixed forward firing 50 cals. Each had 250 rounds. Ultimately, though, this specific factory setup did not see massive production runs. For one, plenty of B-25s were already being modified in the field. Second, outside of the 5th Air Force, there just was not much demand for such a highly specialized attack bomber. But this field engineering experience definitely was not wasted. Almost all later B-25 variants rolled off the assembly line with significantly heavier forward firepower. Interestingly, a similar attempt to turn the B-25 from a standard medium bomber into a dedicated gunship happened in the Mediterranean theater. There, 16 aircraft were modified with 650 cals packed into the nose section. However, the concept just did not catch on in that theater. Before long, the bombers were reverted to their standard glass nose configuration. In North Africa and Southern Europe, Axis fighters were a major headache for the Allies. They inflicted heavy losses on American bombers. What they needed was not more forward-firing offensive firepower, but heavier defensive armament. That is exactly why the 321st Bombardment Group received 57 specially modified B-25C and B-25D bombers right before deploying to Africa. The modification work took place at the Warner Robins Air Logistics Center in Georgia. Engineers removed the vulnerable ventral turret and completely sealed the opening in the belly. Instead, they cut 2 new waist windows. They mounted a single 50 caliber machine gun in each. They also mounted another 50 caliber machine gun in the tail. It was manned by a dedicated gunner to reliably protect the rear of the bomber. Further upgrades to these bombers were carried out at the Sidi Ahmed Air Base near Bizerte in Tunisia. To improve combat survivability, crews installed additional machine guns and significantly upgraded the armor. Specifically, they added armor plating to the pilot's seatbacks, the instrument panel, and the bomb bay bulkhead. They also added armor to the floor and sides of the tail gunner's position. Altogether, around 300 B-25C and B-25D variants went through this extensive refit. Many of these field modifications proved so effective in combat. They later became standard on the production B-25H and B-25J models. In December 1942, United States Army Air Forces engineers began actively experimenting with new armament. They looked into mounting 2 37mm cannons in a special pod right under the bomb bay. In the rear section of this pod, which sat flush against the ventral turret, they added a special compartment for parachute bombs. But the designers did not stop there. In the nose, they mounted 2 50 caliber machine guns and a powerful 75mm cannon. 2 more 50 calibers were placed just ahead of the forward entry hatch. Another 2 went into special cheek blisters on the sides of the fuselage. In February 1943, a B-25C went through this massive overhaul. Flight testing kicked off right away. Unfortunately, the bomber sustained serious damage during a test flight. The aircraft had to be written off. They decided to scrap the experimental program entirely. When the Navy received their Mitchells, they were redesignated. 50 of the B-25C bombers became PBJ-1Cs. Meanwhile, over 150 B-25D models became known as PBJ-1Ds. Many of these naval bombers also went through extensive modifications. They were equipped with modern radar sets and the LORAN navigation system. This technology was cutting edge at the time. Their weapon arsenal was impressive too. A battery of 3 50 caliber machine guns was mounted in the nose. 2 more were added to the cheek mounts on each side of the fuselage. The bomb bay was heavily modified to carry naval mines. In addition, using external hardpoints, the bomber could carry a massive aerial torpedo. It could also carry 10 5-inch HVAR rockets. The standard internal bomb load for this aircraft was 2,000 pounds. If that was not enough, the aircraft could carry an extra 1,000 pounds of bombs on external underwing racks. Another fascinating chapter in this story was the XB-25E prototype. It was built on a standard B-25C airframe. The main feature of this testbed was an innovative thermal anti-icing system. Out on the front lines, crews regularly dealt with severe in-flight icing. This threat was so serious that finding a solution became a top priority for the top brass in the Army Air Forces. Work on this unique prototype kicked off in the winter of 1943 at the experimental department in Inglewood, California. Engineers took a highly creative approach to the problem. They retained the standard carburetor air intakes on the upper engine cowlings. However, they added a dedicated air scoop on the lower cowl for the new anti-icing system. Inside each engine nacelle, they routed a complex network of ducting. It captured exhaust heat from the running engine. This heat was funneled directly into the wings, tail surfaces, and fuselage. To boost the effectiveness of the system, supplemental heaters were installed at critical points along the wings and fuselage. These were strategically placed to keep heat loss to an absolute minimum. This constant circulation of warm air beneath the skin of the bomber theoretically gave ice zero chance to form on the surface. Nicknamed Flamin' Mamie, this heavily modified aircraft was fully ready for testing by early 1944. On February 4th, it took to the skies for the first time with test pilot Joe Barton at the controls. The test profile was rigorous. It required a gradual climb to 20,000 feet, with the crew taking meticulous readings every 1,000 feet. However, on February 11th, during a routine test flight, things went south. Thick smoke suddenly poured from the right wing, followed by open flames. Barton reacted instantly. He managed to pull off a successful emergency landing at nearby Naval Air Station Los Alamitos. Post-flight inspection revealed that the fire was caused by a catastrophic failure in one of the auxiliary heaters. The issue was quickly resolved and test flights resumed by early March. But the final verdict was disappointing. The new thermal anti-icing system proved far too expensive, and it failed to deliver the desired performance. As a result, it never saw mass production. In the summer of 1944, the B-25E was transferred to the NACA research facility in Cleveland, Ohio, for further study. Testing on the bomber continued there for years. It ran all the way until February 1953, when the veteran airframe was finally transferred to Wright Field. The next prototype was also based on the proven B-25C airframe. This was one of 3 experimental bombers in the NA-94 series. Unfortunately, very little information about this specific tail number has survived. Historians still are not sure if it ever even took to the air. All we know is that it was intended as a test bed for an alternative anti-icing system. However, no official reports or documentation of those tests exist today. British Royal Air Force crews got their first look at the new American bomber. They took delivery of an initial batch of 23 B-25Bs, dubbing the aircraft the Mitchell. During this early stage, these aircraft were used strictly as trainers to get their aircrews up to speed. By September 1942, the RAF began fielding the updated B-25C in large numbers. The first 9 aircraft went to No. 98 Squadron, based at RAF West Raynham. The combat debut for these bombers came on January 27, 1943. On this day, 6 aircraft from the squadron flew a daring daylight raid on a large oil depot in occupied Ghent. The mission was a success, scoring direct hits that set the fuel tanks ablaze. But the cost was steep. German fighters shot down 2 of the Mitchells, and heavy flak claimed a third. Later on, another British squadron was equipped with Mitchell bombers. Shortly after that, 3 more squadrons were stood up. They were crewed entirely by pilots and airmen from German-occupied Europe. These included Polish, Dutch, and French units. All these squadrons became a vital part of the 2nd Tactical Air Force. This force provided crucial close air support for the massive Allied push across Europe. The British handed over a separate batch of 173 aircraft to Canada, which was a British dominion at the time. There, these reliable bombers were primarily used for flight crew training and long-range coastal patrols. On top of that, 3 specialized F-10 reconnaissance variants arrived directly from the U.S. Their main mission was to conduct aerial mapping surveys across the remote and harsh regions of the Canadian North. Looking at the overall numbers, Great Britain received 167 B-25Cs and 371 B-25D bombers. They served faithfully in the Royal Air Force right up until mid-1946. After their active service ended, the aircraft were initially placed in storage. Shortly after, they were simply scrapped. A peacetime military just did not need that many combat aircraft anymore. As for Canada, their combat squadrons flew the Mitchell a bit longer. They flew them until 1947, before they too were relegated to training roles. Most of that fleet was eventually written off or returned to the U.S. However, between 1952 and 1954, over 130 additional B-25Ds and B-25Js arrived from the United States. These were distributed among flight schools and training centers. Here, the last of these legendary bombers continued flying all the way up until 1958. Now let us take a closer look inside the aircraft and see how it was put together. The B-25 was a twin-engine, all-metal monoplane. Its fuselage featured a streamlined shape. It roughly resembled an elongated rectangle with rounded corners. The design was exceptionally strong, yet lightweight. Even the cabin floors and bomb bay beams were load-bearing structural components. This helped the aircraft withstand heavy G-loads in flight. Right up front was the Bombardier's greenhouse nose. It provided excellent visibility to the front, top, and sides. Slightly behind and above that was the flight deck. The pilot sat on the left and the co-pilot sat on the right. Located directly beneath the floorboards was the nose gear well. To get to their stations, the pilots, navigator, and bombardier entered through a ventral hatch in the belly of the aircraft. This hatch dropped down a short ladder. Moving around inside was a real challenge for the crew. Once on board, the bombardier literally had to crawl through a narrow tunnel. He went past the nose gear well to reach his station. The navigator was stationed just aft of the pilots. He had 2 small side windows and a top window for celestial navigation. On later models, this was swapped out for a plexiglass astrodome. The heart of the bomber, naturally, was its bomb bay. A very low crawlway ran from the navigator station. It went straight through a set of double doors and directly over the top of the bomb racks. This tunnel allowed the crew to make their way back to the rear section. This is where the radio operator and gunner was stationed. His compartment housed the radio gear, along with the controls for both the top and bottom gun turrets. This whole area was capped off by a heavy armor-plated bulkhead fitted with a door. Past that was the tail compartment. It led all the way back to a plexiglass observation blister at the very rear of the aircraft. The observer did not sit back there. Instead, he lay prone on a fitted pad. He watched the airspace directly behind the bomber to cover their 6 o'clock. Looking at the bomber from above, you would notice its wings had a distinct tapered planform. They were mounted midway up the fuselage. This mid-wing design gave the aircraft excellent balance in the air. The designers did not just bolt the wings to the sides. The center wing section was built right into the fuselage. This created a single, incredibly strong core structure. The outer wing panels were then attached to this center section. Everything was bolted together using heavy-duty structural fittings. This made the whole assembly tough and reliable. On the outside, the wing was wrapped in a smooth aluminum skin. It was supported internally by a dense network of spars and ribs. The aerodynamics were dialed in perfectly too. At the wing root, it used a thick NACA 2307 airfoil. It tapered down to a thinner NACA 4409 profile out toward the tips. Interestingly, that center wing section had a slight upward dihedral. The outer panels extended out with 0 dihedral, sitting perfectly flat. Along the trailing edge of the wing, the engineers installed all-metal Fowler flaps. These were placed inboard of the ailerons used for roll control. To save on weight, the aileron frames were built from lightweight duralumin. They were then covered in doped aviation fabric. The tail section featured that highly recognizable twin-tail configuration. It featured dual vertical stabilizers instead of the usual one. Just like the ailerons, the elevators and rudders relied on a fabric-covered metal framework. All of these control surfaces were fitted with trim tabs. This helped relieve control pressures. It also took the physical load off the pilot's hands during long flights. The bomber's landing gear used a tricycle configuration. It is a standard layout for us today. However, having that nose wheel made takeoffs and landings dramatically easier back then. All 3 gear struts were equipped with heavy-duty oleo-pneumatic shock absorbers. These did a fantastic job soaking up the impact on touchdown. Up front sat a steerable Hughes wheel measuring just under 30 inches in diameter. It came with a specialized shimmy damper to prevent dangerous vibrations during the takeoff roll. The main wheels under the wings were made by Goodyear. They measured a massive 44 inches across. They featured heavy-duty hydraulic brakes operated by the pilot using toe pedals. Just in case the hydraulics failed, the aircraft had a backup pneumatic system. The air bottle was tucked neatly away in the bombardier's compartment. Once airborne, the whole gear system retracted fully. Hydraulics pulled the nose strut up and aft into a dedicated wheel well. Meanwhile, the main wheels retracted rearward into the engine nacelles. Once they were up, the gear doors cycled shut over them. This created a perfectly clean aerodynamic profile. The engineers naturally planned for emergencies too. On early production models, if the gear refused to drop, the crew had to crank mechanical winches by hand. One was up in the bombardier's nose. The other was back with the radio operator. They simplified this on later models by swapping those out for a manual hydraulic hand pump. The cockpit was outfitted with warning lights. If the gear was not locked into place right before landing, a loud gear warning horn would blare through the cockpit. Finally, there was a little extra insurance. This was in case a pilot over-rotated and brought the nose up too high during takeoff. It also helped if they flared too high on landing. A small protective tail bumper was mounted under the rear fuselage. Now let us move on to the heart of the B-25. It was powered by 2 mighty Wright R2600 twin Cyclone engines. These were true monsters of engineering for their time. They were 14-cylinder, twin-row, air-cooled radials. They were also equipped with 2-speed superchargers. They turned giant 3-blade metal Hamilton standard hydromatic propellers. Just imagine. The diameter of each prop reached just over 12.5 feet. The blade pitch adjusted automatically using hydraulics. In case of an engine failure, they could be fully feathered to eliminate unnecessary drag. The engines were mounted to the wing using sturdy steel tube trusses. To keep engine vibration from tearing the airframe apart, heavy-duty rubber shock mounts were used. The engines were enclosed in signature NACA cowlings. These had adjustable trailing edge cowl flaps. This let the crew regulate cooling airflow. Carburetor air was drawn in through a top scoop. The pilot could also open a baffle to pull warmer air from inside the cowling. For desert or rough field operations, some aircraft had dust filters installed over those intakes. The exhaust system also evolved. Early on, exhaust exited through collector rings on the sides of the cowl. These were fitted with finger-style flame dampers. These hid the exhaust glare. This made the bomber harder to spot at night. On later variants, engineers ditched this setup. They used individual exhaust stacks on each cylinder instead. This allowed the engines to breathe better and run more efficiently. The plane used flexible fuel cells made from multiple layers of tough rubber. Starting with the B-25A, they were lined with a self-sealing compound. This automatically closed up bullet holes. Early B-25Cs had 4 tanks in the center wing section. These held a total of 1,253 gallons. Later, fuel capacity was bumped up to 10 tanks. These held 1,553 gallons. This was done by adding extra 301-gallon cells in the outer wing panels. If that was not enough, crews could drop a 584-gallon metal tank right into the bomb bay. On later production blocks like the C-25 and D-20, crews had options. They could choose between a 214-gallon flexible tank or a 334-gallon metal tank in the bomb bay. For long-distance ferry flights, extra tanks were crammed into almost every available corner. They would stick a 100-gallon tank in the bombardier compartment. They also put a 78-gallon tank in the forward crawlway. They even placed a 53-gallon tank in the passageway above the bomb bay. The crew could even transfer fuel between tanks mid-flight. When these bombers were sent to the Soviet Union, they were retrofitted with an inerting system. This pumped neutral gas into the empty space inside the fuel cells. It significantly cut down the fire risk. Soviet engineers also designed their own auxiliary tanks. This included a unique horseshoe-shaped bomb bay tank. It also included a 219-gallon cardboard drop tank. This was externally slung and jettisoned once it ran dry. The oil tanks held about 37 gallons each. They were tucked away in the engine nacelles right behind the firewalls. These were also self-sealing. The oil coolers were mounted horizontally inside the wings, outboard of the nacelles. There were 2 per engine. Cooling airflow was controlled by adjustable shutters. The pilot operated these from the cockpit via a cable system. For cold weather operations on the ground, an immersion heater could be dropped right into the oil tank for preheating. To make cold starts easier during brutal winters, there was an oil dilution system. This thinned the thick oil with aviation gas before engine start. The hydraulic system ran off 2 engine-driven pumps. The hydraulics handled a lot of the heavy lifting. They cycled the landing gear and flaps. They operated the bomb bay doors and controlled the cowl flaps. They also charged the machine guns and powered the main wheel brakes. But what happens if the engine-driven pumps fail in combat? The engineers thought of that too. Starting with the C-5 block, the aircraft got a manual emergency hand pump. On top of that, it had hydraulic accumulators to store backup pressure. One of these accumulators could drop the flaps and open the bomb bay doors. The other gave the pilot enough pressure to pump the wheel brakes exactly 3 times. The electrical system was a single-wire, 24-volt setup. Power came from engine-driven Bendix generators. Backup power was stored in 2 heavy-duty batteries. When the bomber was on the ground, it could be plugged into external power through a standard ground power receptacle. A really interesting detail was the cockpit lighting. Alongside standard lights, they used ultraviolet lamps. These were flipped on during night missions. This allowed the fluorescent markings on the instrument dials and toggle switches to glow. All of this worked without ruining the crew night vision. Since the bomber often flew high-altitude missions, it carried a serious oxygen system. Most variants were fitted with 6 Type G 1 low-pressure oxygen cylinders. The system included 8 A9A regulators. These let the crew manually adjust the oxygen flow. It also included 5 A8A or A8B oxygen masks. That provided 1 mask for each crew member. Ice protection was absolutely critical. To handle this, pneumatic Goodrich de-icer boots were installed on the leading edges of the wings and tail. These literally cracked the ice off by inflating and deflating. The propeller blades were kept clear with an alcohol de-icing fluid. This was fed by an electric pump from a 4.5-gallon tank located in the right engine nacelle. Starting with the C1 block, they routed this same antifreeze mixture to the pilot's windshield, the bombardier's sighting panel, and the carburetor air intakes. Later on, though, they got rid of the fluid system for the bombardier. They swapped it out for a more practical electric windshield wiper. The bomber featured dual flight controls with classic yokes and rudder pedals. The instrument panel was well equipped enough for instrument flying in bad weather. This was made possible by the SCR-269A automatic radio compass. On later blocks, they used the updated SCR-269G. You can easily spot its antenna by the signature teardrop fairing on top of the fuselage. This is seen on the A, B, C, D, and G models. On top of that, the aircraft came with an autopilot. Early models used the reliable Sperry A3 hydraulic unit. Airborne communications were handled by 2 radio sets. The main one was used for air-to-ground communication. It was located at the radio operator gunner's station. The B-25C and B-25D models carried the powerful SCR-274N command radio set. A second, slightly smaller radio was mounted right in the cockpit. This was used for plane-to-plane communication within a formation. And of course, the crew had a standard intercom system. This allowed them to easily talk to each other over the roar of the engines. Starting with the B-25A model, the aircraft received heavy armor protection. This included steel backplates for the pilots about 3/8 of an inch thick. Initially, however, this was only installed for the aircraft commander. The bombardier had his own armor plates. These included a vertical plate 3/8 of an inch thick and a reinforced horizontal floor plate measuring 0.4 inches. The gunners were protected from behind by a solid steel fuselage bulkhead. It was 0.35 inches thick. It featured a special door allowing safe access to the tail section. On the attack versions of the aircraft, the navigator's seat was also fitted with an armored backrest. This was because he was the one reloading the guns. They also added a heavy armor plate in front of the cockpit. They carefully protected the compartment where the heavy 75mm shells were stored. On the later J model, designers added 2 extra armor plates right in front of the instrument panel. Defensive armament varied heavily depending on the variant. On the C and D models, which were the most common early in the war, the bombardier's compartment was fitted with a single 30 caliber machine gun. It carried 600 rounds of ammunition. Interestingly, the nose had 3 separate ball mounts. This allowed the bombardier to shift the weapon from one socket to another in a matter of seconds. This significantly expanded the field of fire. It left fewer blind spots for enemy fighters to exploit. In addition, the aircraft featured 2 Bendix turrets. These included an upper turret and a retractable lower one. Each turret housed twin 50 caliber machine guns with 400 rounds per gun. Electric drives controlled turret rotation and gun elevation. However, the crew had to manually crank the lower turret up and down. Over time, the bombers received upgraded versions of these turrets. Even so, they looked almost identical from the outside. On later production runs, an additional fixed 50 caliber machine gun with 300 rounds was added to the nose. Around the same time, the light, flexible 30 caliber in the nose was swapped out for a 50 caliber. If needed, this flexible gun could be locked firmly in a forward firing position. This allowed the pilot to use it during strafing runs. The evolution of the bomber's armament continued. Starting with the later D models, designers decided to completely ditch the retractable lower turret. Instead, the bomber's firepower was significantly beefed up in other areas. Up front, they added another fixed machine gun. They also increased the ammo capacity for both nose guns to 400 rounds. Waist gun positions were also introduced. 50 caliber machine guns with 250 rounds each were installed in the side windows right behind the wings. They didn't forget about rear defense either. A 50 caliber tailgun position was added, and it was supplied with 400 rounds. As an extra option, external blister pods containing fixed forward-firing machine guns could be mounted on the sides of the fuselage. There were 2 guns on each side. To reduce drag and protect the belts from the elements, the ammunition boxes for these blisters were placed inside the aircraft. They held 400 rounds per gun and were located right in the spacious navigator's compartment. The charging system for the turret machine guns also saw some changes. On early versions like the A, B, and C models, it operated hydraulically. But on the D and G models, designers switched to a simpler and more reliable mechanical cable system. As for the forward machine guns, they had to be manually charged on every single variant of the aircraft. However, the triggers and fire controls were fully electric. For accurate fire, the gun turrets were equipped with optical sights. The pilots had their own optical gun sight. If it ever failed, there was always a classic mechanical backup. This was a standard ring and bead sight. Now let's get to the most important part of any bomber, its payload. On all B-25s up through the C model, the bombs were carried entirely inside the internal bomb bay. The maximum weight for this deadly cargo was 4,400 pounds. The aircraft could carry individual bombs weighing up to 1,000 pounds each. Later on, the design was upgraded with external underwing racks. These could hold additional 500-pound bombs. Thanks to this, the total bomb load jumped to an impressive 6,600 pounds. Starting with the D model, the bomb bay even featured a special reinforced mount right in the center of the aircraft. This could handle a single massive 2,000-pound bomb. The bomb sight was always located in the glass nose. The U.S. Army Air Forces used the famous Norden bomb sight, while export bombers were fitted with British Wimperis systems. When these aircraft were shipped to the Soviet Union, Soviet engineers stripped out the foreign equipment. They then installed their own day and night sights. Designers didn't forget about crew comfort during those long, high-altitude flights either. The B-25 Mitchell was heated by two powerful Stewart-Warner gas heaters. They ran on a fuel mixture fed straight from the left engine's carburetor. These heaters didn't just keep the crew warm, they also ducted heat to the turret mechanisms and machine gun breeches so they wouldn't freeze and jam in combat. The exhaust gases from this system didn't go to waste either. They were routed back to provide carburetor heat. The pilot's windshield and the bombardier's nose glass were kept clear by hot air from a dedicated electric heater. On top of that, the pilots could use flexible hoses to manually defrost any other frosted windows in the cockpit. And for extreme cold, the bomber was wired for heated flight suits. A total of 7 dedicated outlets were placed throughout the aircraft so the crew could plug in their heated gear. If needed, these bombers could be outfitted with a specialized camera for aerial reconnaissance. This camera was mounted in the rear fuselage of the aircraft. To give the lens a clear view of the ground, there was a dedicated camera port in the belly. This was safely protected by a removable cover during normal flight.